A passwordless home lab? Don't use passwords. Boom, done. So in today's crash course, we're going to be building a Homelab service which can be used to manage your SSH, HTTPS, custom applications, or even Kubernetes clusters using one unified service. If you're interested in learning more about the future of a possible passwordless implementation and possibly where the industry is going, or just a unified platform to manage all of your connections such as SSH connections in your security home lab or enterprise business, well, this crash course will be for you. Let's take a deep dive into today's crash course with a project overview. All timestamps will be in the description below, also my notes. So yeah, let's jump in. Okay, so the passwordless home lab. Yes, I know I'm hopping on the trend here. You see the background full of code. But in today's video, I want to overview a passwordless password hybrid and where I think the industry is headed. And you can use this in your home lab, cybersecurity home lab if you're building one, or a business, or if you just want to build this lab environment out, you can follow along here. So let's go ahead and get some background information on first, what is passwordless? Now, I think as the name suggests, you probably know what passwordless is. Basically, it's an authentication method which allows a user to access infrastructure without the use of the traditional form of password, aka knowledge-based authentication. So think of a secret or a passphrase that we've traditionally supplied to an application to get access. Well, passwordless is a different approach. Now, there are different forms of passwordless. Some of them can be such as fingerprints or hardware tokens. As you can see, I have a YubiKey here up in front of the screen. Now, passwordless oftentimes takes the form of using public key cryptography or asymmetric cryptography, where basically you have a private public key pair, and these are passkeys that are used to be supplied to the applications. The public key is supplied to a website or an application, so it's a public knowledge. Everyone can see your public key, theoretically, but your private key stays on your device. And when you're trying to, say, authenticate into a service, the private key can only be used to unlock that particular application access because there's a public-private key pair that's linked together. In today's video, we're going to be using an open source and completely free solution called Teleport. And Teleport implements a passwordless hybrid and issues out these public key certificates to your infrastructure. So let's go ahead and overview how does Teleport work in a very high level. Teleport works through what they call different services. So in today's video, we're going to be deploying a dedicated Teleport server called a Teleport cluster that's going to run several different services. The first service is the Teleport Auth service, and basically think of this as the certificate authority for the cluster. The Teleport Auth service is going to issue out these public keys to the different applications, and we'll see what we're going to deploy today. And then it maintains an audit log of who is logging in using those keys. There's the Teleport Proxy service. So typically, this is the only service that is available from the internet. So if you have, say, an application that's out on the internet or in a different environment, and you want to go into a different network, you can authenticate through the Teleport Proxy service. And then there's the Teleport agents, and these run on the target machines, so on the internet, for example, or on a different network, and it can run different native protocols such as SSH, Kubernetes API, HTTPS. So it's a really powerful service that allows you to enforce security, access control, and have and maintain a good identity log of what's going on. Okay, so here is today's lab topology. We're going to be deploying 3 different applications. First, starting off with the Teleport cluster. Now, this is all going to be happening in the Amazon Web Services space, AWS, because typically this is where a Teleport cluster is going to really show its power compared to just doing it all on a virtual machine within your local computer. So you can sign up for AWS. I do believe you have to link a credit card, unfortunately, but you can also use different services. We'll get to that in a moment. We're then going to deploy an SSH node that's going to also live out on AWS as an EC2 instance. So think a virtual machine. And then we're also going to connect my Windows 10 local laptop via Windows subsystem for Linux or WSL, so that I can connect to my laptop if I wanted to. Prerequisites for this lab. This is what I recommend that you do before you follow along with this video. Of course, we're going to need Teleport. We will be downloading and installing this, so no worries. AWS, that's what I'm going to be using, but you can also use other cloud providers such as Linode, DigitalOcean, or you can even do this on your local computer if you want to play around with the Teleport services through Docker. So you can download Docker Desktop. You're also going to have to download Docker Compose. It's already downloaded default by Docker Desktop. And you can play around with the different services that Teleport offers. I'll make sure to leave the link in the description below to download that Docker lab. And the Docker containers simulate those nodes. So if you don't want to sign up for a cloud service today, you can play around with that. But in today's video, we will be using a cloud provider, AWS. Basic knowledge of Linux is recommended. You don't have to have it, but it's a good idea. I do have a crash course that I'll link here if you're looking to, start your journey into Linux. And then finally, a domain name. We're going to be signing up for a free domain name in today's video, and also a phone or some sort of authentication service with, an authenticator. So I have Google Authenticator installed on my phone, but of course you can use any other type of authentication service. It just has to scan the QR code. Okay, my environment. I have a Windows 10 desktop running today, and I do have Docker Desktop already installed. Like I said, if you want to run this lab locally and you don't want to sign up for a cloud provider, you can download Docker Desktop and follow the Teleport documentation for deploying a local Teleport cluster. I have a Windows subsystem for Linux or WSL 22.04 installation installed on my Windows 10 desktop. And then I also have an AWS account, of course, that I do believe you have to link a credit card to. We'll be using the free tiers in today's video so that it doesn't cost us any money. But unfortunately, I do believe that you have to link a credit card. So like I said, you can use different cloud providers. If you don't want to use AWS, you will have to follow that particular documentation. You can use any operating system, just use whatever you're using. So Windows 11 or Windows 10 or Linux or Mac, it doesn't really matter. So possible use cases for Teleport, Passwordless. What are we doing right with today's video? Today, we're going to be doing a lab, right? So we're going to be showing a possible passwordless implementation or a hybrid model and showing you possibly where the future is going. And it's just a fun lab to create. It's a fun little project. You can implement this into your home lab, whether you have an existing cybersecurity home lab or you're building a home lab. That's a good idea. And then, of course, if you are in a business environment, Teleport can be used for dev, QA, prod, corp environments, and a lot of the industry companies or industry leaders use Teleport for application access. So let's go ahead and jump into our AWS console and get started. Okay, I have Teleport's website up here. Before jumping into today's lab, just wanted to quickly overview the website. So as you can see, like I said, you can do all different types of services and configure this through a Teleport cluster. So you have an application and Kubernetes databases, and of course, server. So if you want to read more about the documentation as well as their cool little native tool that they use to connect the different nodes to the Teleport cluster, you can read this documentation. Like I said, we're going to be registering a completely free domain name and trying to use all free EC2 services so that it doesn't cost us any money. So I am using Freenom, a completely free domain registrar that gives you top level domains for free, but they aren't .coms. They're just like a TK or GQ. They're not great. So let's go ahead and register a domain name. Now, I did go ahead and already sign up for Freenom through an account. I will leave a link in the description below to sign up for Freenom, and then you can register your domain name by just going to myfreenom.com, domains.php. Okay, I will use my security homelab.tk for today's demonstration. Let's go ahead and click Get It Now. And Freenom's website is a little slow, so this will be skipping through here so that just to save time. Here you can choose how long you want your free domain name. I will probably just use the 6 months. So my security home lab, that's totally fine. And let's click continue. Okay, I have created this order. Now we can go to the client area and grab this. So up at services, once you have registered your domain name, you can go to My Domains. Here you can see 2 different domains. Like I said, we're going to be using the mysecurityhomelab.tk. Click Manage Domain, and then click Manage Freenom DNS, and we're just going to leave this screen up here and go to the next tab. The next step is to deploy our teleport cluster out on a cloud service. I am using AWS as hinted at in the intro, but you can also use DigitalOcean, Linode, or any other cloud provider. The reason I'm using AWS is because I have the most familiarity with the AWS ecosystem. If you haven't applied or signed up for an AWS account, unfortunately, you do have to link a credit card or banking information to the account. So if you don't want to incur any costs, you may have to go look out for a free cloud provider, or there are a few programs that you can use. Now, in today's video, we aren't going to be using services that cost money. However, storing data in the cloud, unfortunately, does cost a little bit of money. So I'm looking at my billing management console. I've had a teleport cluster running for a while, and as you can see, if we go to Elastic Compute Cloud, and don't worry about what Elastic Compute Cloud means, we'll go over that in a few moments. As you can see, a virtual machine out here running will incur a few dollars worth of costs per month. So just be mindful of that if you don't want to spend any money. There are programs out there, such as the AWS Educate program that Amazon provides. And you can apply to it to get a free $100 annual credit towards AWS. All you have to do is go to and apply here. And I'm not sure how long it takes to get the account, but you can, of course, get this if you are a student. So make sure to take advantage of that program so that you're not incurring any costs just in case. But like I said, we're going to be using free tier services today. I will also leave a link in the description to create an AWS account, and I do already have one linked with that financial information. So let's go ahead and sign in and deploy this cluster. Okay, so here on my homepage on AWS, if you've never used AWS before, no worries. We're not going to be overviewing the AWS ecosystem, but we will be deploying a couple of virtual machines that live out on AWS's infrastructure. These virtual machines are known as Elastic Compute Cloud, or EC2 instances for short. So you can see here we have EC2. We can go up to Services and then click EC2, and virtually these are just virtual machines that live out in the cloud. If we navigate to Instances here, we can create some new virtual machines, and I'm just going to be using virtual machines. They're called EC2 instances in AWS, but just for the sake of simplicity, we'll call them virtual machines. As you can see, I already have some virtual machines out there. I've been running this as a test environment for a little while using Teleport. Don't worry about these. You probably will see nothing on your screen here. if you haven't, used AWS before. So let's create a new virtual machine using the Launch Instances wizard. So coming up here to the right, Launch Instances, we're just going to create a new virtual machine. Here we have configuration information. So let's create a name for this. Let's just call it My Teleport Cluster. And here we can choose different operating systems. Now, this is where costs can incur if you're not careful. For example, if you use Mac OS or Windows, you probably will incur some costs to use these operating systems. So make sure that you are being careful. You have to make sure that you're using the free tier as your possible solution. So in today's video, we're going to be using Amazon Linux, but you can also use Ubuntu and Debian if you are familiar with those distributions. There are free tiers eligible, but let's just use AWS, keep it simple. Operating systems in the AWS ecosystem are known as Amazon Machine Images, or AMIs. If we click here, Amazon Linux 2 AMI, free tier eligible, you can see some other options. Like I said, keep it to the free tier so that we're not incurring costs. I'm going to be using the default option. You can select the architecture. I'm going to be using 64-bit x86. You can also use ARM. Just use the default here. And then you have the instance type. Once again, make sure that it is free tier eligible. Depending on what you're looking for, if you want higher specifications, of course you can go for it, but that will incur costs. In creating virtual machine instances, AWS does require you to create a key pair. You can use a pre-existing key pair if you've already used AWS. We're going to be creating a new key pair. So if we click create new key pair, and let's just call it my key, you can use the defaults here and then click create key pair. What you're going to see is a new mykey.pem file. This is your private key, so make sure that you store this somewhere securely. And the reason why AWS does this is because, using SSH keys, you can use a different SSH utility, such as PuTTY for Windows, to log into your EC2 instances. Now, we will not be doing that. We're going to be using EC2 Connect through the browser. You'll see here in a moment. So you don't have to worry about these keys in today's video, but make sure to just store that where, no one can find it, right? So maybe encrypt it if you are actually being serious about deploying this. Okay, the last setting is the network settings, and we're going to be creating a new security group. Think of this as a virtual firewall that allows inbound and outbound traffic into your instance. In this case, this is the teleport cluster. This is where it gets a little bit tricky because you don't want to allow all SSH traffic from the internet into your teleport cluster, although it is sitting behind an authentication wall, as you'll see here in a couple of minutes. But you also don't want to, restrict this to the point where you can't log into your teleport cluster. Here's what I recommend. If you are going to create a cybersecurity home lab and you want to have this teleport cluster living out on the cloud, what I would recommend that you do is you allow SSH traffic, and then you also allow HTTPS traffic. We're going to click Edit up here. Call this Teleport Security Group FW for firewall. And here we have SSH traffic, HTTPS traffic. So if you are going to create this teleport cluster, the best idea is to go ahead and either use a custom range of IP addresses or use my IP. What this will do is attach your public IP address to this cluster so that only traffic from your IP address can access this cluster. Anything else will be blocked. And you can also use this for HTTPS. Now, of course, as you can see, it is blanked out on my screen. I'm not going to share my public IP address. But in today's video, I know this is going against my inner security self. I'm actually just going to open this up to the internet. using just anywhere. And the reason for this is just for the sake of demonstration. Now, like I said, if you are somebody who's wanting to deploy this teleport cluster out on the internet, it's probably a good idea to just restrict it to a range or your particular IP address. That's it. So now that we have all this, we can create launch instance. And this will go ahead and create the new instance. So once this has a success message, we can click the view all instances here, and you will see your new teleport cluster. Now, you won't see these virtual machines here, but you will see the new machine that you had just created called my teleport cluster, or whatever you named it. And you can see that there's a status check and it's initializing. So you have to make sure that this is all good. And once this is initialized, you will be able to log in. So clicking refresh a few times. If we click the little checkbox next to my teleport cluster, you can see some information such as a public IP address that's attached to this instance, as well as if you click security, your firewall rules. So maybe you have your HTTP and HTTP rules here, and you have your IP address attached to the source. Our next step is to log in to this cluster. And we can do this using a built-in utility that AWS provides called, I think, EC2 Connect. But basically, it's up here. You can just click Connect. Here, you're going to have your public IP address attached and your EC2 username. That's totally fine. Just keep everything default. Let's click Connect. So as you can see here, we are into our EC2 instance, and this is just a virtual machine that lives out on AWS. So this is where we finally get to do some technical stuff and, deploy this teleport cluster. All right, so time to deploy the teleport cluster, and this is actually pretty easy. You can follow the teleport documentation on their website. We will be using, steps I've already gone through to go ahead and do this. So we have our Amazon Linux 2 machine up. Let's first clear our screen, and we are going to run an update. So to do that, just do sudo yum update, and then go through the prompts with Y. Once that is complete, let's clear the screen again. So what we're first going to do is source some environment variables that are already configured. If we cat the etc os release file, this will tell us some information about our system. We have some variables that are being assigned. So name equals Amazon Linux, version equals 2. This is just a default file that comes with Linux distributions to show the versioning. So if we do source etc os release, what this will do is source these environment variables. So if we do echo $name, you're going to see Amazon Linux, and this will be used for all of these variables here. Next thing I'm going to do is download the teleport repo. So on their documentation, they supply a command. I'm going to be leaving this documentation in the description below here. So I have this already pulled up. And we're going to be using Amazon Linux 2 to set up the teleport cluster. And what we're going to do is use the following two commands. So first, it's going to be sudo yum config manager. We're going to download the teleport repo. So let's copy, right click and paste, and then the end parentheses here. Hitting enter, you're going to see that it grabbed the repo file. The next step is to download the teleport service. So using sudo yum install teleport, we're going to use Y for yes to make sure that's okay. And this will just download. Great. using yes again, and it will be installed here. Okay, so our next step is to go ahead and edit the configuration YAML file with some particular settings. And this is where we're going to go back to our freenom domain. But let's just quickly go through this here. So if we go to the documentation, we're going to create two variables, one called domain, the other called email, and then we are going to configure the domain and email and apply this to our configuration file called teleport.yaml. You'll see this in a moment. Don't worry about it. The first thing we're actually going to do is go back up to our freenom or whatever DNS provider you're using, and we're going to create two records. The first is going to be completely blank, so this is just going to be the root domain. And let's go to our EC2 Connect instance, and you can see that we have a public IP address attached. So let's copy and paste this IP into our domain. Next is adding one more record, and this is going to be a subdomain called login. It can be whatever you want it to be, but I'm just going to use login, and I'm also going to be using the same exact public IP address for the EC2 instance. Once that's done, just click Save Changes. You will see that the records have been added successfully, and the public IP address of this instance will be propagated out to the DNS servers. It does take a few minutes. So back onto our EC2 instance, what we're going to go ahead and do is configure those environment variables and customize our configuration file. So let's clear our screen, and now let's create the environment variables. So first, the domain name. So domain equals what? And in this case, what we're going to be using is what we just registered, login.mysecurityhomelab.dk. For the email, you can use any email. It doesn't have to be the domain. Hit enter, and there we go. Okay, so for our next step, we are going to enter these variables into our teleport configuration file. And we're going to be using a command that is also supplied on the documentation within Teleport. So do make sure to have this tab open when you're configuring this lab environment here. And that is going to be this command. If you see this backslash here, delete it, and then press enter. It is going to say that the permission is denied, but do not worry about that. Now, I did just pause this video real quick when doing this command, but we are actually going to cd or change directory into etc. So just do cd etc and then do an ls -lha. It's going to list a ton of files here. Don't worry about that, because all we're looking for is this teleport YAML, and this is our configuration file. So if we clear our screen, we're going to do sudo nano teleport.yaml. And you can use any text editor you want. I am a basic person, and I use nano. As you can see, we already have our email as well as our domain put into this configuration file. There's actually one more step that we have to do before we deploy our teleport cluster. So going back to our documentation once again, you're going to see that we have this app service. We're going to copy all of this and we're going to customize it. So going all the way to the bottom using the arrow key, we're going to right click, paste. And as you can see, it pastes it here. And so we do need to customize the public ADDR variable. And inside the quotation marks, add in your domain name that you've configured. Make sure that is in the double quotes, and then you can use Control X followed by Y, enter. Okay, so finally, we start the teleport service using that configuration file, and then we can access our teleport cluster. So I know it may seem like a lot, but it's pretty quick if you just follow those documentation steps. So let's use systemctl sudo systemctl start teleport. If we do a systemctl status teleport, you're going to see an active. So now everything is ready. The only thing we need to do is make sure that our public address, linked here, is propagated in the DNS system and is attached to our domain name that we configured. So we can actually go into our machine here and use the dig utility followed by login.mysecurityhome.tk. And make sure that your public IP address is being popped up here in this A record. Going to a new tab, we can now finally access our teleport cluster. So if we do HTTPS followed by login.mysecurityhomelab.tk, you're going to see that teleport is now configured. So now we are in our teleport login portal, and this is the wall that I was talking about earlier in the video. So if you don't really care and you have this prompt open up to the internet, it's up to you. It does enforce 2FA codes, so you can do it either by restricting your public IP address through those virtual firewalls, or if you just want to open up this cluster to the internet, you can. In order to create an account and log in through our web interface to connect our nodes and machines, we are going to go ahead and have to create a user through our EC2 or virtual machine instance that is hosting Teleport. I have went ahead and cleared my screen, and just to double check, we are in the etc path. Now, before supplying the user's add command for creating a Teleport account, we're going to add a new local path. If we use sudo nano sudoers, you're going to see this file. We're going to go ahead and use the arrow key all the way down to where we see defaults. We're going to add a new defaults secure path. So going all the way to the right, we're just going to add a new colon and add this particular path called user local bin so it knows where to source. And then we're just going to do once again, Control X followed by Y, enter. Now we can create this new user and log in to our Teleport cluster. Back on our documentation, this is what we will be using as our way of getting into our cluster. So let's create this new user account by copying and pasting this. Now you can use whatever users or logins you want. So you could add, say, Grant or user123, whatever you want to use. I'm just going to use the 3 defaults that are already supplied. And in fact, we're actually, instead of going to use Ubuntu, we're just going to use Grant. Once we hit enter, this prompt is going to come up with this new URL. And let's supply this to our screen. So let's copy all of this. Getting my tabs all mixed up. Okay, we're going to copy and paste this into a new browser tab. Hit enter. And now we can create our new accounts. So let's get started. It's going to be called Teleport Admin. Create a new secure password, whatever you want it to be. I'm going to be using Bitwarden. And this is where you're going to need a phone or some sort of authenticator app because Teleport enforces default 2FA. So I have Google Authenticator installed on my phone. You can use whatever application that you want to. They recommend Authy. It really doesn't matter. I'm just going to click the scan QR code. It's very self-explanatory. Go up to your screen, and now you have that registered device. So now if we supply our 2FA one-time code and click submit, and we go to dashboard, we are now into our teleport cluster. So like I said, it may seem like a lot to actually deploy this, but if you follow along the documentation, it can take 10 minutes to do this. And now we have a unified way to get access to hundreds of servers, for example, if we wanted to. And this is where we're going to connect both my virtual machine as well as my desktop, home desktop, using WSL. Connecting different nodes to the teleport cluster is really easy. Teleport makes this a very efficient process on the user's behalf. And once we have some nodes connected, we can SSH into our machines just using the teleport cluster. So this gives you a unified overview of all of your different applications. So let's say you have, say, 10 SSH nodes or 10 servers, and you don't want to manage all of those SSH keys. All you need to do is deploy a teleport cluster and then connect all of them to this cluster here. I'll show you that in a moment here, how that works. As hinted at in the beginning of this video, I will be connecting two nodes. I'm going to be connecting my desktop, so this machine here, as well as another EC2 instance living out on AWS just to simulate an SSH node. I will first connect my desktop using Windows subsystem for Linux. If you're not using Windows when following this tutorial, no worries, you can also use Mac or Linux. So going up here, as I'm logged in, I'm going to click the Add Server. As you can see here, there are different applications that we can connect to the teleport cluster, such as servers, databases, Kubernetes clusters, and even desktops. Unfortunately, right now, for Windows desktops, you do have to be connected and managed by Active Directory, but Teleport is working on a feature to include non-AD Windows desktops. For the time being, we're just going to be using servers. So going back to the server here, we're going to click Next, and this command is going to display here on our screen. We're just going to click Copy. Now, I already have Windows subsystem for Linux up and running with a blank screen. What we're going to do is simply right-click, enter. Once this loads, you're going to see a green verified. This is join the cluster. Click Next. And now we can add different users. Let's just see, EC2, grant, and root. Let's add a new OS user, call it test user. Now we can test our connection. Now we can click Finish Setup and then browse existing resources. Now, as you can see here, I do have two laptops up and running. I just paused this video to make sure that I was connecting correctly. So you will only see one of these if you are connecting a laptop through WSL. And make sure you do have to keep this prompt open, up and alive. Unfortunately, that's a caveat with WSL, but let's just see here. If we connect to our cluster, as you can see here, we are now into this server. So it's just an SSH connection, and it's all through the browser. And we can even click Add here. Let's just say we want to SSH into something else. We can, and it's literally that easy. So now you're managing all of your SSH connections through the browser rather than having to manage, like I said, all of those public keys and download an SSH utility. It's just all in a unified design. This is where the teleport can be really useful for creating a cybersecurity home lab, especially if you're using more of a Linux-centric environment. And what is happening on the back end is temporary public key certificates are being issued to these devices, and after a certain time, those public certificates will expire and they'll be reissued. Now that that's done, let's add another EC2 virtual machine and see what happens. So I'm going to exit out of here, leave page, leave that one. And let's go back to EC2 instance connect to an EC2 instance. All right, so back on the AWS console, if we click EC2, go to instances, and let's create a new instance. So let's launch our instance like we did before. We're going to call this my teleport node. And we're going to use Amazon Linux. Once again, everything's going to be the same as we were doing before. And in this time, instead of generating a key pair, we're just going to use the key pair that we already generated before. In our network settings, let's make sure to select the existing security group that we already configured. So if we choose select existing security group, followed by the teleport security group firewall, this is all good. So now we can go ahead and do a launch instance and let this successfully launch. Back to our instances. Once the teleport node is up and running with the green check mark, let's select a little checkbox and then use the EC2 connect wizard to go ahead and connect to this machine. So theoretically, let's just say this is some web server or a reverse proxy or something that you're hosting out on the internet. Maybe you're trying to attack through a cybersecurity home lab, whatever it is that you're trying to do. What we can do here is use teleport, once again, to install the wizard. So let's go to add server. We're going to use the server icon here. Amazon Linux 2 is supported. Click next. We're going to copy this, go to our my teleport node, paste this in. It's the same exact process as WSL. Going back to our teleport cluster, we can see that the server has successfully joined. We'll just use EC2 user and root, click next, and then click finish, and then go to browse existing resources. Okay, so as you can see here, we have our new EC2 instance, and if we click connect, root, for example, we have a root prompt. And then let's go to my desktop. What we can do is just go to, let's see, laptop. Perfect. That's fine. We'll connect through root, for example. And there you go. So now we have a root connection to my laptop. We have connection to different nodes, and this is scalable now, so that now that you can just go out, create 10 nodes, for example, and add all of this. And that is simply how teleport works. It seems like a lot in this tutorial, but it's it's pretty easy once you get the hang of it. We can also connect, of course, through EC2 user. Don't want to use those root accounts unless necessary. And yeah. So that is it for today's video on teleport. Finally, there is a command line utility called TSH. It's Teleport's client tool. And this is going to be helpful if you are wanting to connect to your nodes and get those temporary certificates. So using the TSH command line utility, you can log into your teleport cluster, which then in turn you can go ahead and access all those nodes like we just configured. So it's a very powerful tool if you know how to use it correctly. Okay, so hopefully you learned something new in today's crash course. This was a fun project to implement. Hopefully this will be helpful if you're managing all of your SSH connections. And yeah, until the next video, have a good day and happy learning.